So in this question, there are three parts. The first part is to construct a spatial wave function, right? A wave function for hydrogen in the state that n is equal to 3, l is equal to 2, and m is equal to 1. Then the part B is that we have to check whether this result that we will obtain in part A, if it is properly normalized or not. Fine. And in the last part, we need to find out the expectation value of r raised to power s, right? And the other part of part C is that the we need to find out that for what range of s that is result would be finite, right? So let's start with the solution of this question. Fine. So we are going to first of all deal with part A, in which we need to construct the spatial wave function, right? So the spatial wave function of a hydrogen atom is given by this equation, that is psi n l m wave function, right? Um, bec- this question is basically, it is very simple. The equation that I'm going to write now, right? This spatial wave function equation, it is the main equation, and we would be plugging in the values of some variables in this equation. So okay, the other term over here is at n negative l negative 1, right? So this is l, fine, divided by 2n n plus l cube exponential negative r divided by na. Fine, and the other part is I'm going to write it in a different color because it is very lengthy equation. So divided by na raised to power l. Um, then over here we have l 2l plus 1 and l sub n l minus 1, right? And then again I'm going to use a different color because over here we have 2r divided by na. Now since I ran out of space over here, so I'm writing this last part of the equation in the next line. So next we have y sub l raised to power m of theta phi, right? Let's say that this is equation 1. Now what we are going to do over here is that, as you can see, we need the value of um l, right? This l along this y, right? So it means that we need equations for these variables. And what would we do basically is that after uh, finding the equation of this l and y variable along with other things, we would plug them in over here, right? We would plug them in this equation number 1. Fine, and then we would find out the spatial wave function for the hydrogen atom in the given states. So now over here, this l, it is basically um, an associated it is an associated polynomial, right? So that is one thing, and this y, it's basically a spherical harmonic. Fine. So next we need to write down the equations for these two variables. Fine. So first we will write down the equation for L, right? So let's take a look at that. So L, as you can see over here, right, in this equation, L over here, you can see it has a sub part and a power part, right? So the general equation for it is like L sub p raised to power q of x is equal to c naught sigma j is equal to 0 p negative 1 raised to power j p plus q divided by p negative j q plus j j x raised to power j, right? So let's say that this is equation 2. Now as you can see over here that this is the general form, right? And over here we have written it in this form, right? So it is very much similar to it, right? It has a sub part, it has a power part. So this is the equation for L. Now we will write an equation for Y, that is the spherical harmonic. So Y sub L raised to power m theta phi is equal to 2L plus 1 divided by 4 pi into L minus m divided by L plus m 1 by 2 exponential I m phi p sub L raised to power m cos theta, right? So let's say that this is equation 3. Now similarly, as we compare the general form of y with the y that is present over here, right? It is same, right? So as you can see. So now it means that once we will get the calculated or the solved value of L from equation 2 and y from equation 3, right? So we would just plug them in equation 1 and we would be able to solve our answer or the question whatever that has been given to us, right? So now as you can see over here we have this p variable, right? So what is this p variable? Now this p variable, it is an associated Legendre function, right? So it means that now in order to solve the equation for y, right, this equation 3, we must know the value of p, right? So it means that we need an equation for p. So the equation for p is p sub l raised to power m of x is equal to parenthesis 1 negative x square absolute value m divided by 2 d by dx, again absolute value of m p sub l of x, right? So let's say that this is equation 4. Now similarly as we have been doing from the start of this question, again we have a variable whose value is unknown to us, right? We do not know its value. So again it means that we need to uh, have an equation for p l of x, right? So let's say that's equation, we're not letting it, it's given equation, it is an equation, right, that we have. So l l d by dx raised to power l parenthesis x square negative 1 l, right? Let's say that this is equation 5. Now as you can see over here that we have all the equation, all the variables and their equations, and now we just need to plug in the given information, that is n is equal to 3, l is equal to 2, and m is equal to 1 in equation 3, right? We'll start solving our um, equation from there. So when we can plug it in y equation 3, right? So y sub 2 raised to power n would be equal to negative under root 5 divided by 4 pi into 1 divided by 3 times 2 exponential I phi p sub 2 1 cos theta, right? So now what we are going to do is that we are going to use equation 4, right? So from equation 4 we would have p sub 2 1 x is equal to under root 1 minus x square d by dx p sub 2x, right? Next, obviously we would be using equation 5, right? So from equation 5 plug in the values, right? So you would have p sub 2 of x. Not here, a little bit of maths is um, required, right? But that math is very simple. You just need to plug in the values, open up the parentheses, and then do differentiation, right? I'm not going to do that math because it's very simple. You can do that by on your own. I'm just going to write the end result for this equation. So that would be 1 by 2 parentheses 3 square negative 1, right? So now what we are going to do over here is that we are going to plug this value back over here, right? So we would get p sub 2 1 of x is equal to, again I'm not going to do the math, I'm just going to do the end result, right? That would be under 1 negative x squared 3x, right? um but this x is basically cos theta, right? So we will plug this over here and we'll get that p sub 2 cos theta is equal to 1 minus cos square theta into 3 cos theta, right? So after algebraically manipulating it, we will get p sub 2 raised to power 1 cos theta is equal to 3 cos theta sine theta, right? So then we would plug this value back over here, right? So we would have y sub 2 1 is equal to negative 15 by 8 pi exponential I phi sine theta cos theta, right? Now what we are going to do is that we have the given state of hydrogen, that is n equal to 3, L equal to 2, right? And M equal to 1, right? So for that we need to use um, going back to equation 2, right? So we need to use that L sub 0 raised to power 5 of x is equal to 120, right? So we will be plugging this along with this equation into the overall formula, that is equation 1, right? And then manipulating it algebraically, we would get the solution for part A. So wave function 3 2 1, sorry, spatial wave function is equal to negative 1 over 81, right? Under root pi a raised to power 7 r square exponential negative r divided by 3a sine theta cos theta exponential I phi, right? So this is the solution for part A, right? So next we need to do part B. So part B is very simple. We need to check that whether this result is properly normalized or not, right? So for that we would be integrating it. Fine. So we have, so for we would be integrating it, right? So it means that we would be doing this, right? So we would have psi square d cube r is equal to 1 over pi 1 over 81 square a raised to power 7. Because it's constant, so we can write it outside. Integral r4 exponential negative 2r divided by 3a sine square theta cos square theta. I'm running out of space over here, so I'm going to write the rest in the next line. So it is multiplied with r square sine theta dr d theta d phi, right? So then you will do integration one by one and you will get that it is equal to 2 divided by 81 square a raised to power 7 6 3a divided by 2 raised to power 7 cos cube theta divided by 3 plus cos raised to power 5 theta divided by 5 0 to pi, right? So next what you're going to do is that apply the limits and you will get that it is equal to 1, right? So since the answer is equal to 1, so it means that it is normalized. Fine. So this was the solution for part B. Now the next part is part C, in which we need to find out the expectation value of our S, right? And then we also need to find out the range for which this would be um, finite. So for the expectation value of R S, we have expectation value of R S is equal to 0 to pi, 0 to pi, 0 to infinity, spatial wave function 3 to 1 square r raised to power 2 plus s sine theta dr d theta and d phi, right? So again you will do the integration one by one, right? And first you would do for infinity, then for pi, then for 2 pi, right? So in the end you will get that it would be equal to 720. Again, I'm not going to do all the maths because it's very simple and it's a little bit lengthy. So already this question is very long, so I'm not going to do all the maths, but it's very simple and you can do it on your own. So 1 divided by 720, 3a divided by 2 raised to power is 7 plus s, right? So this is the expectation value for um, our s. Now the last part that we need to solve is that for what range, right? So we need to find out the range, the range of s for which this function would be finite, right? So now as you can see is that the this gamma function, right? This gamma function is it's infinite for at all non-positive integral arguments, right? So it's very much clear from this equation, from this result, that it would be infinite for, at all non-positive integral arguments, right? So it means that s, it must be greater than -7, because only this a range, right? The range that would be greater than -7, um, your result, or what your result, right? It would be finite, fine, because anything, for any integral argument that is non-positive, right? The result would end up being infinite, right? So you need to be careful that s is greater than -7, because only at that your result would be finite. So I know it's very long question, it's very lengthy question, but it's very simple. You can do it on your own. Very simple, very easy. Differentiation and integration is required over here. You can do it on your own. It's very simple, it's very basic. So thank you very much for watching the video.